I'm joined by Rick Ponder of Integrity Fusion Products, National Training Manager.
Correct.
So you know your stuff. Good,
I hope.
because I don't. But we're going to be talking electrofusion. You know, we've done a lot of butt fusion already today. Electrofusion is a little bit different, but the principle is basically the same. You're still melting plastic, sticking it together under pressure, fuses together, you got one piece of pipe.
Correct.
But it's not pipe end to pipe end, right? We're going pipe to fitting,
It's surface to surface.
surface to surface. So we're going to start with a coupler burn.
Mhm.
Coupler looks something like this. You want to tell everybody the different parts of
Sure.
that product, please?
Basically, what you're looking at on electrofusion, as we saw earlier with the butt fusion, in the butt fusion demonstration, you applied heat and pressure to the fusion zone by use of mechanical means. Electrofusion fittings are designed in such a way to where we apply the same heat and the same pressure to the surface of the pipe, but it's done by the design of the fitting itself.
That's right. So inside that fitting is a coil of copper wire. It's connected to these two leads on the outside. We hook it up to a processor, put some current through that wire. That's how we generate heat. Now, the way we generate pressure, I think, is kind of interesting. We have
Correct.
a cutaway of a larger diameter coupler. Do you want to tell us all about that,
Sure.
please?
If you take a look at electrofusion coupler, when you're looking at it, you have two areas which are of equal importance. You have one area where you see the wires that are embedded. That's the fusion zone. That's where the heat is actually going to be generated and applied to the surface of the pipe. But you also have areas where there are no wires, and those are called cold zones. So as that heat generates in that zone there and the plastic melts and it begins to move out, it dams up in the cold zone area, and that's where the interfacial pressures are actually generated.
Right. So that's those little gaps on
That
either
is
side of
correct,
the
on both
side of the
sides.
wire. So the plastic heats up, it heats, it expands, and that's where our pressure comes from.
That is correct.
Great. Well, I see you're all set up to do a 2-inch coupler. Should we go ahead and fuse it up?
Sure.
Great. So butt fusion, we go clean it, shave it, heat it, fuse it. Pretty much doing the same stuff with electrofusion, but each step looks a little bit
A little bit
different,
different.
right?
That's correct. So what we're going to do first is the first thing we want to do is we want to identify where the fitting is actually going to go. On an electrofusion coupler, we're going to make sure that we're going to do half the distance of the coupler. And I'm going to put what I call a witness mark there, and that's going to be our stab depth. I'll do that on both sides of the pipe end. And then what I'm going to do is I'm going to highlight the area where I'm going to need to remove the material and shave it off. Okay. The next step is actually going to be the removal of the plastic material itself.
So why is this step so important?
On the surface of all pipes, there's a layer of oxidation, and we need to remove 7 to 10 thousandths of material, basically the thickness of 2 sheets of paper. We need to get that off so that we can have virgin resin exposed.
So this device here is called a rotary peeler.
That is
You know,
correct.
Rick, once in a while in the field, we see guys using a paint scraper. Is that okay?
Not so much.
Okay.
That used to be a common way of doing things, but now with the Plastic Pipe Institute, they have basically recommended that we use a peeler type of scraper that has a removable.
That's right. So that tool is designed and calibrated to remove that 7 to 10 thousandths of an inch.
That is.
Hand scraper, you're just kind of guessing.
That's right.
So I can see, looks like you're removing a little ribbon, pretty much the same thing we take off the pipe ends when we do our butt fusion. And you've marked half the coupler depth, right? That's an appropriate stab depth. That ensures that all those copper wires within the coupler are making contact with our pipe. So we go and do the same thing on the other side. Rick, what sizes will that particular peeler prepare?
This will do 3 through 6 inch.
Well, I hope it does 2 through 6 inch because that's what you're
Well,
working on.
2 through 6.
2 through
That's
6
correct.
inch. Okay, good. Okay, so all our witness marks are gone, so we know that oxidized layer has been removed.
That is correct.
What's next?
Okay, the next thing, even though the area has been, we're down to virgin resin, there's always the possibility that you're going to have some sort of inadvertent contamination. It may be through wind blowing, dust, rain, moisture, sweating on it, who knows, something like that. So we want to take the extra step of cleaning the surface area one more time before we assemble the joint with a mixture. Basically, it's a 90% mixture of isopropyl alcohol and water, and that's it, no additives, just a 90% alcohol and water.
Okay, so that isopropyl evaporates quickly.
Correct.
Water is the only other thing in there, so we know nothing is left on the pipe.
That's right.
Are we going to do something about that?
We can.
Okay, good. Beautiful. Now, you left your coupler in the plastic. Is that an important step?
That is important. Electrofusion couplers, when they're manufactured, are basically in a clean environment. and they're packaged and they're sent this way. And this is to keep it from becoming contaminated during shipping. And you want to make sure that the electrofusion fitting stays in the package until you're ready to assemble the joint.
All right.
So
Are we ready?
We are ready.
Let's get a look at the inside of that coupler before you put it on.
Okay.
So there are little plastic tabs in there. Tell us about those.
Those are little stops on smaller diameter electrofusion couplers. That allows you to put those on a fitting without it going all the way on.
Okay.
They can be knocked out real easy.
Okay.
One final step is we're going to make sure and clean the inside of the coils. Even though it's clean, it's just a precautionary step that we
just to make sure there's no barrier in that fusion interface.
That is correct. Now we're going to put this on to where our stab marks are. We're going to bring the two ends together. This would be what we're basically going to call aligning the pipe assembly. We want to align it and restrain it during fusion.
Okay, so the restraint is to maintain a proper alignment. Also, if that pipe heats up, it might want to push out of the coupler.
It could.
So that restraint keeps everything connected, keeps everything together, keeps our molten material dammed up between those cold zones.
That's correct.
All right.
Okay, so we're in place. It's all assembled. It's all ready to go. Now we're going to hook up the electrofusion processor.
So this processor is made by Integrity. Does it matter who makes the coupler?
No,
your processor will fuse anyone's fitting.
It will fuse anybody's fitting. It's what makes it universal is the barcode technology. We have a barcode on all of our fittings, and you just scan it with a barcode scanner.
And that'll convey the fusion parameters, voltage, and time to the processor.
All the fusion data is embedded in the barcode itself.
And if that barcode's damaged or gets ripped off,
what you have, you can do a hard fusion basically, or a manual fusion, so time and voltage, and you have that information that's basically molded on the fitting itself, where you're going to see it'll tell you what voltage is required and how much time, and then you can actually manually enter it in the processor. You can continue on with the fusion at that time.
All right, let's go ahead.
So we're going to go ahead and scan that. We know we got it. We got a good green to go. Oh, hang on, I got to do this. Now we're going to scan it. Okay, now what that has done is I have input all the fusion parameters into the processor. We can see that it is a coupling. We have the manufacturer type. We know it's a 2-inch fitting, 39.5 volts at 70 seconds, and I can confirm that information on the label itself.
Okay, so we agree with the processor. Yes. I guess we're ready to fuse.
We are ready to go. So we're going to go ahead and hit OK. It's going to walk us through a series of prompts. The first one is going to ask us if we've scraped and cleaned the pipe. And we have done that, so we're going to proceed. Now we're at the point where it's a go, no-go prompt right here. So if everything's all ready, if it's good and I feel comfortable with it, I'm going to go ahead and hit start. If not, I'll hit no and I'll abort and I'll do whatever changes I need to make. And as you can see right now, we're beginning to energize the fitting. It's telling me what my voltage on my line is, and we're doing a countdown on the fusion time.
That's it? We're fusing?
We're fusing.
Not much to it.
That's it.
Now, I noticed the processor wanted to know, did you scrape and clean the pipe? That's a really important step. And when you guys see failures, it's often that step that was missed or not done properly, right?
Typically, we see about 90% of all failures would be because of improper pipe preparation.
Okay, you've got a sample over here that really illustrates how important that is. You want to tell us a little bit about it?
Sure. What we have right here is a coupler, and half of the coupler here was prepared properly, and it did indeed fuse. We can see where the plastic actually melted, and it moved out to the cold zones, and it dammed up. And the other part, there was no preparation at all, and the pipe did come out. But you can see on the surface here where the pipe did expand and it moved to the cold zones, and it tried to do what it was designed to do. But because of the contamination on the surface, it kept it from fusing.
So when you cut that sample up, did that pipe
basically
fell apart?
Yep.
So pretty important to do your prep work correctly. Really important to get people trained up on electrofusion. And Integrity, you guys offer that remotely?
We do.
Can you tell us a little bit about that program?
Yes, we just recently launched our new online Electrofusion training program for small diameter electrofusion fittings, 12-inch and smaller. So if you have any questions or need to know any more about it, you can contact us at Integrity Fusion, and we'll be glad to let you know about it.
Great. Yeah, we'll get Rick's email up on the screen at the end of the day, along with all the other presenters. So that's an Electrofusion coupler. Really common in the municipal market are Electrofusion saddles for service connections. And you brought one with you today, didn't you?
We did, yes.
Okay. So a process really similar here. but a little bit different because we're not fusing 2 pipes to 1 fitting, right? We don't have 4 cold zones. Our coil of copper wire looks a little different in there, right?
It's the same process. It follows the same rules. The design of the fitting is just a little bit different. When you
let's get the camera in there nice and tight and tell us how that works.
When you take a look at this fitting right here, you're going to see the area where the wires are embedded. That is the fusion zone. Okay, that's where the heat's going to be generated. You also have the areas where there are no wires in the middle and all around it. That's the cold zones. So as the plastic heats up and moves, it's going to hit those cold zones. It's going to dam up and do what it's supposed to do.
And how are we going to restrain that fitting so we generate pressure?
This particular fitting has what we call the sacrificial clamp on it. Okay, this basically, it goes on there and it stays on there. After it fuses, you can leave it on or you can take it off if you want. Other restraint devices may be ratchet straps. They could be size on size, under style cantilever clamps. It just depends on the manufacturer and the particular design of the fitting that they have.
Yeah, I think we saw some of those other styles out on the pipe display earlier. This one pretty simple and easy to use, though.
Yes.
Okay.
It is.
So I see you've already done a little bit of prep work. You've marked the area to peel, and you've even done half the peeling, so we don't have to sit here and watch you. So you get a slightly larger tool. Let's go ahead and finish it off. So are you occasionally going to take one of those ribbons that falls off and just make sure you're within that appropriate tolerance?
I think it's appropriate to monitor that, and you're also paying attention to your witness marks, because on some pipes you may have a low spot, which would require you to go back and re-scrape it again.
Right. Yeah, 4-inch like this, the pipe's going to be pretty round. The larger the pipe gets, the greater the chance it might have some ovality, might have a persistent flat spot. So those witness marks, absolutely essential to make sure that entire oxidized layer has been removed. And it looks like they're all coming off right now, right?
They are.
Good.
Okay.
And if you put a caliper on that ribbon and it is a little off, you replace the blade, replace the springs, pretty simple fix, right? Okay.
Yes. It's basically just a knock out and put in.
Okay. And then occasionally this processor needs to be calibrated too, right?
Yeah. Yes, every 2 years.
Every 2 years, and ship it back to Integrity, or how's that work?
Correct. Yes.
Okay.
Just contact us, and then we'll send you. We'll just get the paperwork sent up, and we'll send it in for calibration.
Okay.
Bring it into us.
All right. So we peeled. Now we're going to get our isopropyl again.
We are going to get the isopropyl once again. We're going to clean the area.
So no barrier to fusion here.
Correct.
No oxidized layer, no contamination. Now we're ready to get that fitting on.
That is correct.
So fitting snaps on. Oh, you practiced it, so. Okay. Sure. All right, so you've got 2 bolts on there. Can we get the camera on the other side just so everyone can see that? And are you just going to bottom those out? Is that how you know you're tight enough? Okay.
That's all we're doing. That's the way it is designed.
And you check the gap between the fitting and pipe before you fuse? Okay. Just to make sure there's no...
Typically, to check your gap, we can use a zip strip, small zip strip, to just make sure that there's no gap underneath.
Okay.
There.
All right, so we bottomed those out. Looks like we're ready to go. Let's go ahead and hook the processor up and get her scanned and fused.
Okay, it's turned off here. Okay, it's going to go through its initialization. Okay, so we are ready to go.
It's the same routine. We're going to plug those leads into those. Have to go. Is there a positive and negative? You can plug them in anyway.
There are no positive negatives on these.
Okay. So that puts a little current through that copper wire. Make sure there's nothing damaged within that fitting. Then once again, we scan the barcode.
That's correct.
I see on the processor, it wants to fuse at 39.5 volts for 100 seconds.
That's correct.
Then we take a look at the label. We agree.
There
So
you
we're
go.
ready to fuse. Well,
Ready
we
to
don't
rock.
want to waste 100 seconds. Everybody saw how that processor works.
That's it.
We have one last demo here, and this is one of the best applications of Electrofusion. We see this all the time. It's called a spool piece repair. There are a lot of ways to repair polyethylene. You hardly ever need to do it, but there are situations where it does get damaged. Third-party damage is typically what we see. You can slap a repair clamp on. That's great. That works. But an Electrofusion spool, I think, is the best technique because you maintain your 100% polyethylene monolithic leak-free system. So I'll help you get set up here.
Okay.
We're going to pretend this is just one continuous piece of 4-inch pipe. It's been in service for years until someone hits it with their excavator. So what do we do to fix this with all polyethylene?
Okay. If I have a damaged piece of pipe, say right in here, what I want to do is I want to cut out the damaged piece of pipe. Then I'm going to cut another, what I call a pup's point or pup joint, the same size. And it's going to be, that way it will fit exactly in there. And then I can go ahead and prepare the surfaces of the pipe being repaired and the pup joint.
Yeah, you did a lot more peeling on this one.
I did, yeah. Takes a lot less time doing this way. And then what we're going to do is we're going to put the coupler on, only this time we're putting the coupler on all the way. And that's how come we have the full coupling pipe.
Okay, what about those stops that we saw?
There's no stops in this right here. If you have a small diameter fitting that has the stops in it, you can go ahead and knock it out and push it on all the way. It's not going to hinder it whatsoever.
So those are engineered to come out easily.
That is correct.
Okay.
Once we do that, we're going to slip it in, and then we can just bring it in.
Slide our fitting over.
And you'll have your stab marks on there, and then you're ready to energize both couplers, and you'll have your repair.
And that's
spool
it.
done.
We fuse them both up like we did with the 2-inch.
That's it.
Maintain a 100% polyethylene system.
Absolutely.
Very cool. Well, Rick, thank you for being here. Dan, do we have any questions for Rick before I let him go? We're all set? Okay.